Okay, I'm going to give you a really quick lesson on spherical geometry. I don't have any idea if Professor Horton would cover this in great detail and make you do the problems. I am not. But I do want to talk to you about it because I think it is a very interesting thing that if you are not ever exposed to it, then you're kind of missing out on some interesting thinking. So, Euclidean geometry, or what we call plane geometry, is what all of our theorems and our postulates and formulas and stuff that you have been learning this entire school year is based on the fact that we're working on a flat surface. That's what Euclidean geometry means. It's a flat, two-dimensional surface. And all of the formulas and theorems and things stem from that fact. We're dealing with a flat surface. And things, for example, like parallel lines, we know that they never intersect. Well, that's true only in plane geometry. When you start looking at different type of geometries, and we call it non-Euclidean, is like a dividing line. Euclidean means a flat surface. Non-Euclidean means it's some other surface. What other surfaces can you have? There's a bunch of them, but spherical is the next one. You've got different definitions and different properties that take place in spherical geometry. For example, if you imagine, let me go to somewhere where I can draw. Okay, so let's imagine that I gave you a word problem. Let's say I'm going to start off at my house. Okay, this is my house right here. And I'm going to leave my house and I'm going to walk, let's say, 5 miles south. Well, we know that 5 miles south means I'm walking in this direction, given that, north is up, south is down, east is this way, west is over here. So I'm going to walk, what did I say, 5 miles? I'm not walking 5 miles. I'll walk 3 miles. How about that? I'll walk 3 miles. I'm then going to turn west and I'm going to walk 3 miles. And then I'm going to turn and go north and I'm going to walk 3 miles. Okay. And I claim that once I do all of that walking, that I am back at my house. Well, you draw the picture in Euclidean geometry or plane geometry, and we see that that is impossible. That if I walk south and then I walk west and then I walk north, I'm going to have to walk east in order to get home. But in non-Euclidean spherical geometry, that's not the case. Let's say, just for drawing purposes, that this is my house. I'm going to walk 3 miles south. Then I'm going to walk 3 miles west. And then when I turn around and walk 3 miles north, I am back at my house. That's because I'm walking along a sphere, not a flat surface. And this is obviously possible. It'd have to be more than 3 miles. But in spherical geometry, because we're on a flat surface, north, south, east, and west follow different rules because we're not on a flat surface. Another thing that's possible in spherical geometry is great circles. Great circles are defined to be circles that go through they're called antipodal points. They're like at the very tip top of the globe and at the very bottom, but they don't have to be at the top and the bottom. They could be at any opposite. Anti means opposite podal points. So they just have to be completely opposite each other on a round surface. If you go straight, if you stuck a pole from one antipodal point to the other antipodal point, you would be going directly through the center of that sphere. Great circles go around the globe. In spherical geometry, great circles are defined as lines, and they're also defined as parallel lines but yet they still intersect. So that's just another interesting fact that when you get off a flat piece of paper, or when you get off of a flat surface, when you get out of plane geometry, some of the things that we learned in plane geometry are not true. The last thing that I think is interesting, we've kind of already hit on it. Let me see if I can find a picture. Yeah. Triangles in plane geometry, we know have to have 180 degrees. In spherical geometry, a triangle can have more than 180 degrees. And there's, proofs that show that and all that kind of stuff. But, and a right angle in spherical geometry is not necessarily 90 degrees, which is how I was able to, on this thing right here, make a triangle out of, walking 3 miles, walking 3 miles, walking 3 miles. That triangle, that 90 degree, which would be 90 degrees in plane geometry, turning, from going south to going west, that would be a 90-degree angle in plane geometry. In spherical geometry, it would not be. It would probably be a little bit more. But anyway, so that is really all I'm going to talk to you about in terms of spherical geometry. Just know that it exists, and that just know that the definitions and postulates, things that we know to be true, are not the same as they are in plane geometry. I'm not going to give you an assignment from this section.